The Bible called them plagues. Today we call them natural disasters, but they're actually one and the same. And the biblical plagues are coming back. Thousands of years ago, toxic algae made life difficult for humanity. The algae poisoned the drinking water, made cesspools stink, and caused massive deaths of fish. Industrialization and globalization have made these algae more common than ever, despite technical progress and modern science. But committed scientists and ecologists are refusing to give up. "3,500 years ago, the Egyptian pharaoh had a dream. He decided to build a new royal palace, far away from the centers of government. But the project was too large for the Egyptians alone. They needed foreign workers. So Pharaoh enslaved the people of Israel. After long years of oppression, the slaves demanded their freedom. When Pharaoh refused to let God's people go, Yahweh threatened to visit plagues on the Egyptians. The Lord first terrified the Egyptians by threatening to poison the Nile, the great river that supplied their entire livelihood.
Moses raised his staff in the presence of Pharaoh and his officials and struck the water of the Nile, and all the water was changed into blood. The fish in the Nile died, and the river smelled so bad that the Egyptians could not drink its water. Blood was everywhere in Egypt. What happens when the Nile floods in September is that further down the sources of the Nile, all the snow melts on the mountains and the waters rush down, and there's red earth. And these red soil particles are washed down as well. So there's two reasons the Nile turns red. One is the red soil particles, but the Egyptians will be familiar with that every year. So that turns the Nile red, but not vivid red. And so in addition to the red soil particles, there was these special red algae as well. And the red algae bloomed, and it's the algae which emit the toxins.
Toxic algae are still around today. This is what they look like. They are single-celled organisms that can emit nerve poisons. Every day, somewhere in the world, people die of their toxins. The algal bloom colors the water blood red or green, but sometimes it is colorless and so remains invisible and unnoticed, until it has done a great deal of damage. Northern Germany, 2002. A reception at an upmarket restaurant. The guests were enjoying the buffet. Including seafood. Dangerous seafood, as it turned out. After eating mussels, 30 people fell ill with stomach cramps, profuse sweating and vomiting. They needed urgent medical care. It hardly seemed possible. Mussels are among the most carefully monitored foods in Germany. Shellfish is usually tested where it is harvested. In this case, it was in Denmark. But the first tests revealed nothing. No one had complained about the samples, and yet the poisonings happened. Something wasn't right. It was a case for Dr. Stefan Efkermann. At the Institute for Ichthyology, the study of fish, in Cuxhaven, he and his team dissected some of the mussels, pureed some parts, prepared solutions, spun them in the centrifuge, and distilled them, all using the latest techniques. Dr. Efkermann was able to find out how the mussels came to be poisoned.
Das Chromatogramm zeigt direkt, dass wir sehr hohe Konzentrationen des Algengift, Toxins, Okadasäure in der Muschel enthalten sind. Und eine grobe Abschätzung deutet darauf hin, dass der Grenzwert um den Faktor 10 überschritten ist.
Reliable testing is essential because algal toxins poison over 60,000 people around the world every year. The toxins are found in fish, mussels and other shellfish. They have strange names, ASP, DSP or PSP, and every one of them is on the increase.
Das ist also eine Übersicht über die PSP-Toxine. Man sieht also hier auch sehr schön, dass das Ganze schon europaweit beobachtet wurde. Gerade jetzt gab es in der Presse Mitteilungen über 2 Todesfälle im Zusammenhang mit dem Verzehr von Austern. Und genau hier vermutet man, dass PSP-Toxine ursächlich für diese Vergiftungen waren. Also eine typische PSP-Vergiftung fängt in der Regel mit einem Kribbeln in den Extremitäten, also heißt in den Fingern oder auch in den Füßen an. Und in schlimmeren Fällen kommt es zu Lähmungserscheinungen, die schlimmstenfalls sogar mit dem Tod enden können.
The Alfred Wegener Institute in Bremerhaven. This is where the director of UNESCO's worldwide coordinating body for harmful algae, Professor Alan Sembella, draws all the threads together.
Salut, Patrick. No problem, yeah.
A French colleague has called about 2 deaths in Brittany.
And it never...
It's still not clear whether they resulted from eating toxic oysters, but one thing is sure. A warning was issued in France about the danger from toxic algae. Shellfish growers protested against the official precautions until the 2 people died.
Yes. Okay then.
Professor Sembella promises his French colleague technical support for any necessary tests.
Na, ja, Bretagne, war das Brest?
The experts are working to coordinate their efforts. Alerts are arriving from every continent. Calls for help from food standards authorities, fishermen and coastal communities.
Das ist nur Cyanobakterien.
Norwegen geht da wirklich ziemlich weit hoch.
Ja.
In recent decades, the number of incidents has multiplied. Are toxic algae spreading?
It's when these blooms are in high magnitude, in other words, they produce a lot of biomass, or when they produce a high amount of toxin per cell, that we start to see the negative effects being expressed. But these tend to be rather unusual circumstances, and what we'd like to do is to be able to predict these a little bit better, to first of all understand what is the cause of the toxicity, and then how can we predict and model what will happen when these toxic blooms occur.
The Institute's researchers know they can't afford to wait for reports to filter through to them. Where there's a need, they have to get out and take samples to try to understand what is happening in the environment. Aboard the research vessel Heinke, they're heading for the North Sea. Alan Sembella, a Canadian, is based in Bremerhaven because it's the centre of international algae research. The poison of the algae he's searching for can be more dangerous than chemical weapons. He and his colleagues are trying to find out why toxic algae are suddenly reproducing so quickly. A lot more is going on in the depths of the North Sea than the researchers would like. Almost everywhere they encounter minuscule algae, half animal, half plant. They're trying to determine the likely consequences of the algae's sudden growth. Western Florida, a holiday paradise on the Gulf of Mexico. The coast is lined with luxury homes with spectacular sea views. And here, of all places, there are frequent dangerous algal blooms. The area is known for them. In 2006, the effects were disastrous. Hundreds of thousands of dead fish on the beaches were the first sign of toxic algae poisoning. Sadly, the fish were not the only victims. Through the fish, the toxic microorganisms enter the seabird's food chain, spelling death to gulls, sea eagles and pelicans. Often the algae colour the sea blood red, creating a so-called red tide. But sometimes the algal bloom is a poisonous green, as it is here. Algae of both colours are dangerous. Even large fish die after eating algae-infested seagrass. Dolphins can't always avoid the algae either. This dolphin was found dead off the Florida coast. Predators had mauled its body, but its ugly wounds could not have been the cause of the animal's death. Alex Kostidis takes samples for the pathology lab of the Fish and Wildlife Conservation Commission.
It's not as common, but in the last few years we've been getting more and more dolphins. In 2004 we had 107 bottlenose dolphins die. So animals get paralyzed and they can't breathe at the surface, or their diaphragm won't work, and even if they're at the surface they can't take a breath. And we think that was from red tide. They had stomachs full of little fish that eat algae, and the fish tested very high for brevetoxin, the toxin in red tide.
Tissue samples will provide more precise information. Alex removes parts of the lungs and the liver and sends them to the laboratory. The coasts of Canada run for thousands of kilometres. The first settlers had their own experience of toxic algae. The pioneer captain George Vancouver wrote of poisonings in his logbook. Does this mean that poisonous algae were always found here, but are now spreading faster than ever before? Why should they be? Scientists think some species may have been introduced unintentionally. In 1987, 129 Canadians were poisoned by algae-infested mussels in a single incident. 3 of them died. It was a traumatic event for a country where much of the population lives on the coast. Canada's mussel industry is a significant source of employment and national income. As the risks of harvesting wild mussels in the open sea become harder to judge, aqua farming is becoming increasingly important. 40% of Canada's mussels are now farmed. The advantage is that it's easier to monitor. The disadvantage is that toxic algae can cause millions of dollars worth of damage in one hit. Mussel farmers often have to interrupt their harvesting. John Stairs has been lucky. His harvest area has been closed only once in the last 2 years. But he has to make regular checks on his mussels. toxic algae barely affect the mussels themselves. They only harm the people who eat the shellfish when the toxin level is too high. So, every week, the authorities test the mussels. If the toxin level is too high, the farmers stop harvesting until it returns to normal. If there's enough clean water, the mussels will recover.
We all test for toxic algae once a week, and they have to have 3 clean tests in a row, and then they can open up again. So nothing happens to the mussels. They continue to grow and live, and so they just get a little bigger. So you have 2 weeks off where you can paint your building or something.
If there's an outbreak of food poisoning, the whole market for mussels collapses. So the mussel farmers have a strong interest in monitoring algae growth. It's the same for salmon farmers. If the current carries colonies of algae into the salmon cages, thousands of valuable salmon will perish. It's a nightmare for the farmers. In biblical Egypt, all the fish in the river died, and the river stank, and the people could not drink of the water. And Pharaoh called all his high priests and magicians to the banks of the Nile. The magicians raised their staffs and applied their secret arts. They feared the competition of a god they did not know, and they set to work with all their might. They, too, managed to turn the water into blood. That they could achieve. But however hard they tried, they could not get rid of the algae that were already there.
Well, it's said that the magicians were able to do the same thing for the first plague. So they couldn't stop it, but they also, I mean, it's a curious story in a sense. I think maybe this algae maybe bloomed twice. The algae came out and bloomed, and the Nile turned to blood, and then it sort of died down. And then the magicians, I think they struck the Nile with their staff, and the whole thing happened again. So they demonstrated they could do this first plague. They couldn't do the later plagues, but they couldn't stop the plague. So that again, the fact that these magicians could do it demonstrates it was a natural event.
Canada is Alan Sembella's home. He studied toxic algae in Canada for many years before joining the Alfred Wegener Institute in Germany. Now he's joining his former colleagues. They're collecting vital new data. Professor Sembella and Stefan Kirschberg of Dalhousie University are on their way to inspect some very special marker buoys off the city of Halifax. Solar-powered computers in the buoys record the water temperature, the currents, salinity, and the presence of particles suspended in the water. Not just on the surface, but also deep down on the ocean floor. For the algae don't remain on the surface. They colonize the whole of the water column. The sensors on the ocean floor must be kept in good working order, and they are regularly checked. The sensors are fitted with photocells that measure sunlight. If too little light penetrates to the lower levels, it's a strong sign of algae growth. The photocells must be cleaned continually because they quickly become covered in tiny algae.
In some cases, the algae form a superficial layer on top of the water. That's a so-called classic red tide, where you can actually see water discoloration. But much more often, the bloom is in fact subsurface. You can't see anything from looking with your naked eye into the water column. Show how they do We can use this kind of instrumentation to track the bloom, where it actually is, how deep is it in the water column. This is very important because if most of the biomass is below the surface, it's invisible from the surface. We want to know exactly where in the water column the mass of the bloom is located.
It isn't possible to put buoys along the entire coast, so the researchers have developed mobile devices that emit light impulses. Reflections in the water supply information about the thickness of the toxic algae. The devices are lowered into the water, where they can check depths that are beyond the reach of the aqua farmers.
Hold on a second.
The researchers know they may encounter toxic algae at any time. Then they must hope they've found it early enough to raise the alarm.
Surface tear. Surface. All right, it's teared.
The mussel farmers support these tests. An efficient early warning system is crucial. Relatively few algae are toxic. Some are harmless, while others are nutritious and beneficial. And the same species may be toxic at one time and harmless at others. No one knows why. Exotic species of algae are appearing more and more where they were never seen before. Often they are unintentionally introduced by man. World trade is one culprit. Freighters and tankers in coastal waters take on ballast water to stabilize them for long voyages, especially when they're not fully loaded. When they reach their destination, they pump the water out, and with it billions of tiny stowaways that must then adapt to a new home. In this way, algae, bacteria, and fish eggs are spread from one continent to another. They arrive in places where they have no natural predators. Laboratories regularly identify high levels of diverse microbes in ballast tanks. The microbes include disease-carrying bacteria and toxic algae. The coast of the island of Elba. The fishermen here have a big problem with an introduced pest. Christian Lott of the Hydra Marine Institute is charting the relentless progress of an exotic form of seaweed. It's believed to have been released when an aquarium was cleaned.
Caulerpa taxifolia kommt aus den Tropen und ist ins Mittelmeer eingeschleppt worden durch einen Aquarienunfall im Ozeanografischen Museum von Monaco. Und von dort aus, das sind immerhin 500 Kilometer, nehmen wir an, dass sie mit Yachtankern eingeschleppt wurden, hier in die Bucht von Marina di Campo.
Divers are about to search the sea floor 15 meters down. The water looks clear. But here, too, the green plague is growing. Caulerpa taxifolia is a mysterious marine plant that spreads at astonishing speed. Where there was once a variety of marine vegetation, it creates a green desert. It also destroys the habitats of many fish species. The Hydra team measures the damaged area and maps the spread of the weed. It's not only taking over the feeding grounds of native species, it's also releasing toxins into the environment. Normally, this tropical algae needs a water temperature of at least 20 degrees Celsius to survive. But it has mutated to survive in much cooler water, even in the Mediterranean winter. Genetic analysis has shown that all the caulerpa found in the Mediterranean is descended from the same original piece of seaweed, a single branch of a single plant. And there's no way to get rid of it.
Man hat versucht, Caulerpa taxifolia mit Kupfersalzen beispielsweise zu vergiften. Kupfer ist ein sehr starkes Gift für viele, viele Pflanzen und Algen. Man hat versucht, mit elektrischem Strom die zu vertreiben oder auch zu vergiften durch Elektrolyse, giftige Gase, die dann entstehen, Chlorgas beispielsweise. Man hat versucht, durch große schwarze Plastikfolien den ganzen Meeresboden abzudecken, um denen das Licht wegzunehmen. Der Erfolg war in den meisten Fällen sehr mäßig. Caulerpa taxifolia ist unheimlich resistent und kann diese ganzen Anfeindungen meist viel besser abpuffern als viele angestammte Tier- und Pflanzenarten. Die gehen eher ein als Caulerpa. Die einzige Strategie, die wirklich was hilft, ist Ausreißen an kleinen Flecken, wo man sicher sein kann, dass man auch alle Bruchstücke einsammelt. Alles andere ist zum Scheitern verurteilt. Das wurde vielfach versucht mit vielen, vielen Tauchern. Es gibt ein großes Tohuwabohu unter Wasser und nur kleinste Bruchstücke dieser Alge können eine neue Kolonie begründen. Die wachsen einfach wieder aus. Wenn man die übersieht, sät man die Alge, statt sie komplett auszuradieren.
Their only chance is to spot a brand new colony before it has established itself. Then they may be able to get rid of it completely. It's a colossal task. The Nile, a kind of historical test case for the spread of algae, was crucial for the survival of the ancient Egyptians. Their dependence on it made them particularly vulnerable.
The Nile is the lifeblood of Egypt, and it provided them with fresh water. And of course, if you didn't have fresh water, you couldn't live.
When the water turned to blood, the Nile began to stink. The people and their animals could no longer drink from it. The Egyptians searched desperately for alternatives.
So what the Egyptians did, and maybe this is something they had learnt before, they dug along the banks of the Nile, and then they got drinking water. So what happened there was that this impure water in the Nile was filtered by the sand on the banks of the Nile, and they were able to drink this drinking water. So that was a trick they'd learned, probably from history.
The ancient Egyptians already saw that deadly algae could be present in rivers far from the sea. Any body of water that is still or slow flowing is at risk. Any swimming lake can turn out to be a trap. In still water, algae may thrive too well, especially if the water entering the lake contains nitrates and phosphates from untreated wastewater or from agriculture. Here, the connection between human activity and algae growth is especially clear. Some of these blooming algae are extremely toxic. Unfortunately, it's very difficult to distinguish them visually from harmless members of the same species. They cause nausea and serious illnesses. Rainer Kohrmeier of the Austrian Institute for Limnology is studying microorganisms in freshwater bodies near Salzburg. To do so, he breeds blue-green algae, or cyanobacteria. He has established that these algae can be directly harmful to humans in drinking water.
Ja, wenn sehr viel von diesen Giften im Wasser dann vorkommt und dieses Wasser dann also getrunken wird, dann können also die Konzentrationen so hoch werden, dass sie Menschen auch vergiften. Ja. Und solche Vergiftungsfälle sind bekannt, leider Gottes, aber gerade durch hohe Dichten von Cyanobakterien kommen da Konzentrationen zustande, die also äußerst gefährlich sind. Eines der klassischen Symptome sind also Nekrosen in der Leber, die dann auch zum Tod führen können.
Blue-green algae, which may also be red, can attack reservoirs of drinking water. In some countries, this has led to frighteningly high rates of cancer. That is why Dr. Kohrmeier is studying endangered inland lakes, such as the Mondsee in Austria. Already, special efforts have been made, and not just in Austria, to clean up lakes like this. But it's still too early to give the all clear. Dr. Kohrmeier takes samples from a depth of 12 meters. He has a theory. He has noticed that some algae are able to descend to a safe place at the bottom of the lake and not die in the mud on the lake floor. They can remain there in a kind of hibernation for decades, until conditions on the surface become more favorable. His theory proves correct. There are hundreds of algae in every drop. They have joined together in small groups called colonies.
Im Prinzip bestehen diese Fäden aus Hunderten von Einzelzellen, die also scheibchenartig aneinandergereiht sind. Man sieht jetzt auch schon diese Hohlkörper, diese gasförmigen Hohlkörper, die also jetzt den Zellen ihren Auftrieb geben und auch dafür verantwortlich sind, warum diese Zellen jetzt nicht absinken können und sich auch jetzt in 12 Meter Tiefe einschichten können. Das sind diese stark lichtbrechenden Strukturen, die man im Mikroskop erkennen kann.
Another trick helps the blue-green algae survive. In the depths, they transform the weak rays of sunlight into a luminous red. They use this not for communication, like other deep-sea creatures, but for photosynthesis. Scientists have just made this discovery. In Florida, too, there is an alert. The continuing fine weather of the late summer is aggravating the algae problem. The water temperature is still high, which encourages algae growth. Islands of poisonous algae form in the open sea, with the risk that they will drift towards the beaches. Fish and Wildlife Commission staff are taking samples at various points 15 miles offshore. But they have to break off. This is storm season. A rapidly approaching tornado forces them to head back to shore. But even the few samples they've been able to collect show that the situation is becoming serious. On the beaches, another algal bloom is already killing millions of fish. In some places, tons of dead fish are removed every morning. Sarasota Beach is a holiday resort, popular with both convalescing pensioners and families with children. The water temperature is 30 degrees Celsius. But many visitors find that their eyes start to water, and almost everyone is coughing. When single cells of the toxic algae burst in the spray of the breakers, they release 16 different neurotoxins, highly dangerous nerve poisons. Everyone knows about it, but it doesn't stop them going to the beach. The Marine Laboratory has set up monitoring devices that are checked every 2 hours. Solid particles from the sea breeze are trapped in their filters. In the air, they have found a large number of neurotoxins, which affect everyone. In the nearby car park, doctors from the Moat Marine Laboratory stop visitors and measure their lung capacity before and after they've been to the beach.
Deep breath in, blow it out hard and fast. Blow, 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 keep blowing, squeeze.
Almost everyone is affected. People who are susceptible to asthma are most at risk.
Almost there, and take a break.
I know that wasn't
All right.
very good.
Initially, you can exacerbate the asthma, and that can make people, so they have to start taking medications, they miss work, they miss school, they have to go to emergency rooms. And also, we've also looked at whether it can cause increases in things like pneumonia, bronchitis, other respiratory diseases that are associated with asthma.
Although the danger to health is well known, none of the beaches is closed, and no bans are imposed. America is a free country.
They don't, however, have authority to make you get out of the water. It's just a recommendation. So you can still decide if you want to go in the water or not.
The study signs up volunteers for a period of months to wear a device that records how many poisonous cells they are inhaling. This allows the scientists to establish the exact relationship between the neurotoxins and breathing difficulties. And these are the tiny culprits, hundreds of a millimetre long. Carenia brevis. They are found singly off the coast of Florida all through the year. But when the numbers exceed a certain threshold, the situation becomes critical. An algal bloom can last for weeks or months. Recently, one lasted longer than a year. Here, a scientist is counting the organisms. In some places, the concentration is now more than 1 million cells per litre of water. In Bremerhaven, Alan Sembella receives reports from all over the world every morning. He is trying to put the different pieces of the puzzle together. And it's becoming clearer and clearer which factors are most likely responsible for the growth of the algae.
Certainly, there is evidence over the last few decades of man-made changes to coastal zones that do appear to be related to the spreading or the introduction of bloom organisms. And one in particular that's been invoked is the nutrient enrichment, putting more nutrients into coastal waters, certainly does appear to favor some kinds of blooms which have harmful effects.
But which nutrients play a decisive part? Alan Sembella's colleague, Gary Kirkpatrick, is also keen to find out. And where better to do so than here in Florida, where there are alarmingly frequent red tides. The latest technology should help them.
Launching the glider, it's going to be you and I recovering it.
This is a highly sophisticated underwater research vehicle, originally designed for military use. It's wireless and is designed to work entirely independently for several days, using advanced electronics to investigate the ocean depths.
Run this check out. Over.
The underwater probe is controlled from space by a satellite.
Pitch
We
motor.
set it to lab mode.
Running status.mi again.
The men from the Moat laboratory are using it for the first time. They are trying to establish contact with the command center via a satellite link that should relay signals to the probe and collect the data from it. The order to dive must be confirmed by the command center.
Standing on his head now.
Now the probe is on its own. It will collect data for several days, transmitting information about the presence of algae and the exact composition of the seawater. Temperature plays a key role. That much is clear. So it's also clear that climate change is directly involved. Civilization comes at a price.
You know, if there's any doubt.
Certainly there are a lot more people living in Florida and living along the coast now, and that means there's more material that humans are throwing away, wastes and pollution and so on, getting into the water. All those things have potential to impact the red tide, but we don't have enough scientific evidence to say that it's one item or another.
Ready? Yeah.
So far, there's not enough information. But scientists hope the new data will show exactly who and what is responsible for the rapid growth of the algal blooms. And once they know, it may be possible to do something about it. Or, in the worst case, we will find out there's very little we can do, other than find a weapon to fight toxic algae. The scientists at the Moat Laboratory are looking into that question right now. They're experimenting with ozone and clay and other substances to see if they can destroy toxic algae. After this treatment, many algae do sink to the seabed and die. However, plants and animals on the ocean floor suffocate, and other sea creatures are killed as well. So far, chemical treatments have also proven unsatisfactory. The side effects are too unpredictable. On top of that, the area to be treated is vast and the cost is enormous, as is the disruption to nature.
We have hundreds and even sometimes thousands of square miles that are involved with a red tide bloom. So economically and logistically, it isn't feasible to even consider applying some agent over that large of an area. An additional method for control of red tide would be biological control. Here, various organisms such as bacteria, which actually attack the red tide organism itself, but we'd have to be very careful when, where, and how such biological agents could be used, and we'd have to be certain that they didn't continue to cause a problem after the red tide was gone.
Back in Bremerhaven, the scientists are working on the biggest puzzle of all. Why do only some algae produce poison? With a microscope, Alan Sembella's colleague, Dr. Urban Tillman, examines the mysterious single-celled creatures.
Wir versuchen herauszubekommen, welchen Vorteil im Zusammenspiel mit anderen Planktonorganismen für die Giftproduzenten resultieren kann. Und hier versuchen wir ganz gezielt zu untersuchen, inwieweit Gifte auf Fraß einen Einfluss haben können. Eventuell wird auch die Giftproduktion erst angeregt durch Botenstoffe, die von anderen Planktonorganismen ausgesandt werden.
Tillman watches as algae appear to fire arrows, paralyzing their victims with a nerve poison before dragging them away. Then he finds harmless algae that actually hunt the poisonous algae.
Hier sieht man zum Beispiel, wie Algen der Gattung Chatonella, ganz berüchtigt für große Fischsterben, auch gefressen werden von kleinen einzelligen Fressern. Hier mit einem ganz speziellen Mechanismus, wie ein kleiner Saugrüssel, kommen diese Fresser an, durchstoßen die Zellwand und saugen einzelne Chloroplasten der giftigen Alge in ihren Zellkörper rein.
So the poison of toxic algae is not always enough to ward off predators. Perhaps these indestructible single-celled suckers could be a miracle weapon against toxic algae. A biological weapon, algae versus algae. There are thousands of varieties of algae, and only 60 of them are toxic. But every year, these few tiny organisms are responsible for 60,000 reported cases of poisoning, 1,000 of them fatal, as well as for massive fish deaths. Is there a biological reason behind this?
Certainly they're not produced to kill fish. They're not produced to kill human beings that eat shellfish. They're not produced to kill whales or marine animals or to disrupt marine ecosystems. They have some function. And it could well be that in many cases the fact that they are toxic to human beings and seabirds may be somewhat of an artifact of the real reason why these compounds are being produced. So what we would like to do is to be able to find the mechanisms of the toxin production and to determine what are really the ecological role of these compounds, because they evolved presumably hundreds of millions of years ago. They're not new. They occurred before human beings were here and probably will be there long after human beings are gone from the face of the earth.
The ancient Egyptians would not have been able to see the individual cells of the algae, only their catastrophic effects. But the message behind the poisoning of their lifeline, the Nile, must have got through to them. It was a first warning that they had to do things differently.
I wouldn't see these as a warning sent by God, because my belief in a God is a God who's a God of love. And so I think these are disasters which are happening in our natural world, but there's something we can do to prevent them and to minimize them. And I think we have a responsibility to do that. So I think, we have a responsibility to leave our world a better place for our children and grandchildren.
In the Bible, the plague of contaminated water abated after 7 days. But Pharaoh hardened his heart. He would not let the Israelites go. The fish stocks in the Nile were almost exhausted. There were no fish left to eat the spawn of the frogs and the toads. The next plagues, culminating in the invasion of the stinging, disease-bringing flies, were now inevitable.